Matter. It makes up air, ice, human beings, everything. It's composed of atoms, and no matter how solid something feels, those atoms are jiggling around like crazy. Temperature is really a measure of all that jiggling, the kinetic energy of anything's atoms. The scale of that temperature ranges from lead ions smashed in the Large Hadron Collider to 5.5 trillion Kelvin to absolute zero, the point where all atomic jiggling stops. Thing is, when the mercury plummets, we don't actually feel the temperature. We feel the flow of energy. We feel the heat. Feel my heat. Or really, we feel the unheat, because cold can never move into something. It's heat flowing out. There's 3 ways that energy is transferred. Conduction is the transfer of heat between solid objects. Convection uses the movement of fluids, while radiation relies on electromagnetic waves. The sensation of being cold is really just energy moving from one temperature to another, causing our matter to jiggle a little bit less, and the matter around us to jiggle a little bit more. It's just like when a rubber ball gives up some of its energy every time it bounces, eventually coming to a stop. The universe steals energy from us and keeps it for itself. It's very greedy, that universe. So which is hotter, a boiling tea kettle or an iceberg? The kettle, obviously, right? Put a thermometer in both and boiling water will register higher. But the iceberg contains more heat, more thermal energy. I mean, think about it. If I drop them both in a swimming pool of ultra-cold liquid nitrogen, which would warm up the pool more? It's not the tea kettle, I'll tell you that much. Once we leave Earth, it gets even more complicated. We think of space as a vacuum, but it isn't completely empty. If we collected a cubic meter of deep space, say between 2 galaxies, we might only count 100 atoms. And if you were floating out there, you'd freeze almost instantly. But if we measure those atoms, they might be at temperatures up to 1,000,000 Kelvin. That's because temperature doesn't depend on the number of jiggling atoms we're counting, 100 or 100 trillion, just their average kinetic energy. If we put a thermometer out there, it wouldn't read anything. There's just not enough matter to matter. So if temperature is all about kinetic energy, why does a wind on a cold day make us feel even colder? Shouldn't the air be moving faster and be hotter? Well, on the smallest scales, the atoms and molecules in the air and in our skin are actually jiggling so fast already that adding a little wind doesn't make any difference. So my atoms are jiggling however fast they do at normal body temperature, and the atoms in the winter air are jiggling slower. My atoms bump into the air's less jiggly atoms and transfer some vibration. I lose heat and feel cold. When a wind comes along, it brings in a fresh batch of less jiggly air, and I give up even more of my heat. It's the same reason that blowing on a cup of tea causes it to cool down. Heat transfer is why a tile floor feels colder than the carpet, because it's denser. There's more atoms packed closer together, ready to steal your precious warm vibrations. It's why you'll freeze to death faster in cold water than in snow. It's why you can put your hand in a hot oven, but touching a hot pan will burn you. And it's why you should never, ever touch your tongue to a frozen flagpole, even if someone triple dog dares you. Really, we feel cold because it's the law. The second law, to be exact. We feel cold because the universe is on a long, slow mission to even everything out, increasing entropy, lowering energy, until the whole universe is at equilibrium. Life is about the opposite. All our inner chemistry and biology is a way to hold on to energy, to keep it for ourselves and do interesting things with it. That's cool. Stay curious.